I'm going to show you how to derive the quadratic formula from the general equations, the quadratic equation, the standard form. So we start with ax squared plus bx plus c equals 0, and we are assuming that a, b, c's are integers, and a, of course, cannot be a 0. Because if a is 0, the x squared term will be gone, and you don't have a quadratic function anymore. Instead, you have just a linear function. So what we do is just like any other process, when we start with deriving the formula, we have to make sure everything's in order and that we cannot have a, basically the first coefficient in front of the x squared term cannot be anything other than a 1. So to ensure that, we have to divide everything by a, because the reason for that is because we are going to be using complete and square technique to derive this formula. So after we divide everything by a, what we end up with is x squared plus b over b divided by a times x plus c over a equal to 0. And we, of course, will get rid of this c over a because we don't need it and we want to complete our own square. And if you recall from completing the square technique, we complete the square by cutting this in half and then we square it, and as a result you will see this. Now we can add this value. Remember that what I just added is the actual area of the missing square, and since we added to one side, we have to add it to both sides. Okay. Remember, we are using the completing the square technique. So this side now is factorable. It's just basically the original side of the square add on to what we just with the extension on each side that will make up the missing square. So this is the side of the new square. And on the other side, of course, is, notice I'm trying to find the common denominator. In this case, we have a as the denominator and 4a squared, so the LCD will be 4a squared. And over here, whatever I do to the bottom, I have to do that to the top, so I multiply 4a to both top and bottom. This is what I have. And now I can certainly take the square root on both sides to get rid of the square here on the left-hand side. And what I end up with is x plus b over 2a equals to, now don't forget, plus or minus, the square root of b squared minus 4 times a times c, everything over 4a squared. So you can kind of see that the quadratic formula is taking shape at this point. We are close to finishing it up. And now the last step is to go ahead and move this b over 2a over by subtracting it both sides. Just like that. Now after subtracting both sides, I just write it as is, negative b over 2a plus or minus square root of b squared minus 4 times a times c, everything over 2a. And I realize that since both of them have the same denominator, I can just quickly combine them together and write everything over 2a. And there you have it. You can clearly see I now have the quadratic formula, and it is obviously derived from the standard equation using the completing the square technique to get to the quadratic formula. And this is the reason why the quadratic formula will also give you the same exact answers as if you were doing completing the square or trying to factor it, using the traditional method. But since the quadratic formula is derived from the following standard equations, you can use it to solve for any equation that is not even factorable. All you have to do is just make sure everything's in order. You can extract your a and b's and c's, and you can substitute those values inside the formula and solve for them. And that's it.